Okay, number 6. The question says, patients with heart attack symptoms arrive at an emergency room either by ambulance or self-transportation provided by themselves, family, or friends. When a patient arrives at the emergency room, the time of arrival is recorded. The time when the patient diagnostic treatment begins is also recorded. An administrator of a large hospital wanted to determine whether the mean wait time between arrival and diagnostic treatment for patients with heart attack symptoms differs according to the mode of transportation. A random sample of 150 patients with heart attack symptoms who had reported to the emergency room was selected. For each patient, the mode of transportation and wait time were recorded. Summary statistics for each mode of transportation are shown in the table below. Alright, so in this table, you have both the mode of transportation, which is the ambulance taking you to the emergency room, and yourself or your friend or someone from your family taking you to the emergency room. And the sample size are very similar. It's 77 for the ambulance taking you, and for yourself, a friend, or your family taking you, it's 73. So those are very similar. It's only a 4 patient difference. The mean wait time, so for both of these, the ambulance is smaller. So the ambulance for the mean wait time is around 6 minutes, and then if you take yourself, it's around 8 minutes. And then the standard deviation of wait times, 4.3 for ambulance taking you, and for yourself, a friend or family taking you, it's 5.16. Okay, so let's attack question A. So question A tells us to use a 99% confidence interval to estimate the difference between the mean wait times for ambulance transported patients and self-transported patients at the emergency room. Alright, so we're going to go through and we're going to do PANTS, which we've been going through the past 2 units. And probably the most important thing in AP Stats is knowing how to do PANTS and knowing how to do phantoms, because that's pretty much what AP Stats is. It's the meat of it. So for P, this is just pretty much naming our variables, so later on down the road, we can, the reader, or if you're referring back to it, you know what each variable you state later on is referring back to and what it means. So U of A represents the mean wait time of patients who arrive by ambulance, and mu of S represents the mean wait time of patients who arrive by self-transportation. Alright, so that's simple, and now we're going to move on to A, the A part of PANTS, which is assumptions. So for the assumptions, we're going to assume that it's a random sample. This is basically stated because in the question, it is stated that it is a random sample, so that's obviously going to be part of our assumptions. And also, we must assume that there's enough patients. So this is easily done through the easy calculation of 10 times 150, which equals 1,500. So you just take that and, yeah, anyways. Also, you must assume that the mode of transportation is randomly selected. So we're assuming that the 150 patients are randomly selected by the administrator of the large hospital, which is stated in the question. And also that the population distribution does not matter because N is greater than 40. As you can see in the question, 150 patients is greater than 40, and then both the sample sizes, even when divided between ambulance and self-transportation, those are also both greater than 40, so therefore we can proceed. So next we're going to do the N part of PANTS. So N is name that test, and we're going to do a 2-sample interval. So we're going to do this because there is clearly 2 samples, the ambulance and the self, and because it just makes most sense for the question. This is the equation for the 2 samples, the interval, and boom, boom, boom. That's the equation. So we're going to take that equation and we're going to throw in the numbers from the table that was given to us from the question, and we're going to get our confidence interval, our 99% confidence interval. All right, let's do it. So we're going to do mu of A minus mu of S, so ambulance-driven and self-driven to the emergency room, plus or minus the T star times the standard deviation squared over the standard deviation of A over the population of A squared, plus the standard deviation of S squared over the population of S. So simply we're just going to do 77 minus 1, which equals 76. 73 minus 1, which equals 72. We're going to pick 72 because if you have a smaller number, you can be more confident in the interval you get, because it's more likely of a chance that it's going to be within that interval, because it's just smaller, so there's more room for it to be in. So we're going to do 72, and then to do this, we're going to go to this. This is to find the T-star, and we're going to look at, since we're doing a 99% confidence interval, we're going to go to 70. But as you can see here, there is no 70. So we're going to go down just again, so we're more confident that it's going to be within our margins. So 60 and 99%, it's going to be at around 2.66. So we're going to put that in, and then we have, so the mu minus mu, so that's 6.04 minus 8.3, that's going to be a negative number, negative 2.26. Plus or minus 2.66, which is what we just got from that sheet that you gave us. And we're going to do the standard deviations, the population. We're just going to do all the math. You don't need to go through that. You know what it is. And that's negative 2.26 plus or minus 2.0688. If you do the addition, you're going to get negative 0.1912. And then when you do the subtraction, it's going to be negative 4.3288. And then to put that in other words, it's going to be, the interval is going to be negative 4.3288 to, oh, that should be a negative, my bad, negative 0.1912. So that's the math of the equation. That's really the only math that we need to know for these kind of questions. And that's pretty much the meat of the question. That pretty much shows us what we need. Now, this is what we need for the question. And then this just sums up T. S just sums up T. So S, which is the statement in context, I said that from this sample of 150 patients, we are 99% confident, because we said 99% confidence interval, that the population's waiting time is between negative 4.3288 and negative 0.1912 minutes. All right, so simple enough. We just pantsed it, and we got the meat of the question. At first, I just did these two, but then I realized I didn't understand what this meant. So I was like, all right, I got to pants the whole thing. I'm doing it wrong. And now that I got what the variables meant, what we did, what the assumptions were, and what type of test we were doing, I really understood why this is significant and why this is significant to the question. And yeah, so pretty much I learned you gotta go through pants. Even though it's a pain in the neck, you gotta go through pants, because it will really show you how significant every single step is for most questions that have to do with confidence intervals. And then we're going to go to question B. Question B is, based only on this confidence interval, do you think the difference in the mean wait time is statistically significant? Justify your answer. So basically, we're going to go we're going to find the ho and the ha. So the ho is that they are equal. The average for my bad. The mean for ambulance-driven and self-driven is equal, and the ha is the opposite, which is the ambulance-driven minus the self-driven does not equal 0. But based off of the 99% confidence interval that we got right here, you can clearly see that 0 is not within negative 4.3288 and negative 0.1912. So therefore, we can reject the ho at the 0.01 significance interval. All right, Mr. Shaheen, thank you for coming through this with me. I know it sounded like I was talking fast, but I did like 4 tries, like redoing it, so I knew what I was saying, and I understood it more and more every single time I spoke it. So there you go, Mr. Dean. Have fun grading these. Yep, and have a great rest of your day. Bye, Mr. Sheen.